Everybody. Hopefully you can hear me. My name is Mr. Bliss. I am going to help you guys out with using trigonometric functions, so sine, cosine, and tangent, to solve word problems. I know, everybody's favorite, but it's going to be fun. So let's take a look at example 1. This is just a review of what you guys hopefully learned last time. We're going to start with trying to find the sine of angle A, cosine of angle A, and tangent of angle A. And I'm just going to do it for the first triangle. You guys are going to do it for the small triangle, and then we'll talk about why you got the answers you got. All right, so triangle, big triangle, angle A. I always like to mark off the angle that I'm talking about so I can focus on that angle right there. So the sine of A is opposite over hypotenuse. So you look at A, you go to the opposite side, which is the 8, and then the hypotenuse is always the longest side, and it's always opposite the right angle. So I look at the right angle, and I go to the opposite side of that. So this is my hypotenuse. This is the opposite side. And the one that is left is your adjacent side. So the 15 is my adjacent side. All right, so the sine of A is opposite over hypotenuse. So we go opposite, which is 8, over the hypotenuse, which is 17. So 8 divided by 17, we take out our calculator. 8 divided by 17, I got 0.47. So that's our ratio. Now we're going to do the cosine. So cosine is adjacent over hypotenuse. Hypotenuse stays 17. And then the adjacent side is this 15 next to the A. So 15 over 17. We divide 15 divided by 17, and I got 0.88. Finally, tangent is opposite over adjacent. So again, the opposite side, look at angle A, that's where we're focusing on. And we go to the opposite, which is 8, and the adjacent side is 15. So 8 divided by 15, I got 0.5333, so 0.53. All right, pause the video in a second, but I want you guys to do the same thing for the small triangle. So pause the video, try it out, see what you get for the sine of angle A, cosine of angle A, tangent of angle A. All right, welcome back. Hopefully you paused it and tried it out for yourself. But you guys should find out that you guys got the same exact numbers for the tangent, cosine, and sine of angle A for the small triangle, because the big triangle is twice as big as the small triangle. So that means these two triangles are similar triangles. Right? And you guys probably learned in a previous lesson that similar triangles are going to have the same trig ratios. All right. So that was our quick review. Let's jump into a word problem. All right. We're on vacation someday in the future. We go to Alaska, and there is a Sitka spruce tree in Alaska, and we're trying to find the height of the tree. So we stand 45 feet from the base of the tree. So we're at the base of the tree, and we go 45 feet. And we take out our phone or some other measuring device, and we look at the top of the tree, and we measure that to be 59 degrees. And now we're trying to find the height of our tree. So focus our attention on this angle. What do we know and what are we given? Right. We know this distance here is 45. Is that the opposite, the hypotenuse, or the adjacent? That is the adjacent side. So that's what we know. What are we looking for? We're looking for the height of this tree. How does the height, or how does this side of that triangle compare to our angle? That is the opposite side of our angle. So I'm going to write opposite here. All right, so we know the adjacent. We're trying to find the opposite. So now we have to ask ourselves, which trig ratio are we going to use? Sine, cosine, or tangent? Okay. So opposite, adjacent. Which one of these uses the opposite and the adjacent? Tangent uses the opposite and the adjacent. All right, so we're going to use tangent. So the tangent of any angle A is the opposite over the hypotenuse. So our angle A is 59 degrees. Our opposite is what we're trying to find, the height. And our hypotenuse, nope, I messed up. Let's get rid of that. I'm sorry. That is the adjacent. I don't know what hypotenuse. So our adjacent side is 45. So we're going to put 45 there. So now we got to solve this. You can either solve for tangent first, or you can multiply both sides by 45. I'm just going to get rid of tangent of 59 degrees. So I take out my calculator, 59 tangent, I get 1.66 equals h over 45. So now how do I solve that? 1.66 equals h over 45. I need to multiply both sides by 45. The opposite of dividing by 45, multiplying by 45. So these guys are going to cancel out. And 1.66 times 45, I got about 74.7. For our final answer, the height of the tree is about 74.7 feet. Right. Make sure you use units. All right. We're trying to find the height of something. So what units are we using? All right. Example 3. You are skiing on a mountain with an altitude of 1,200 feet. The angle of depression is 21 degrees. Find the distance x you ski down the mountain to the nearest foot. All right, so a few things we got to talk about. Altitude. What does altitude mean? When you think of altitude, think of an airplane. Right? The altitude of an airplane is how high your airplane is. So we're skiing on a mountain with an altitude of 1,200 feet. So I know this mountain goes higher, but I'm just going to make this distance here 1,200. Make a nice triangle there. Angle of depression, we'll get back to. We're skiing down the mountain. So here's my little guy skiing down the mountain. And we are trying to find out how far down the mountain he's going. So that is going to be this length here, x. Right. So you can see we have this nice triangle. Our angle of depression. Your teacher may have talked about angle of depression. Your teacher may not have. So your angle of depression is how your eyes move. So we have angle of elevation. Elevation, your eyes are going to go up. Angle of depression, your eyes are going to go down. So you got to imagine you're the skier. Right? This skier is having an angle of depression. So usually we look straight ahead like that, but his eyes are going down. So that's going to be 21 degrees there. Right? So this angle of depression of that angle is 21 degrees. The good thing is we remember way back in, I don't know, September, October, when we looked at parallel lines. We have this line is going to be parallel to this line. So this angle is 21 degrees. This angle here is also 21 degrees. Right. So now we have our triangle. We have an angle, we have a side, and we have a side that we're looking for. So again, we ask ourselves, what are we going to use? Sine, cosine, or tangent? Right. So what do they give us? An angle, and they give us the opposite side. Right. So what do we know? We know the opposite. So it could be sine, it could be tangent. What are we trying to find? This is the distance along the mountain slope, so that's going to be our longest side. Again, your hypotenuse is opposite your right angle, so we're trying to find the hypotenuse. So we're going to use sine. So again, sine of our angle is opposite over hypotenuse. So our angle is 21 degrees. Sine of 21 degrees is our opposite, 1200, over our hypotenuse, x. So take out your calculator. Sine of 21, I got 0.358. So I'm just going to write 0.358. If you want to round that up to 0.36, I'm okay with that. All right, so now we have to solve that equation. 0.358 equals 1200 divided by x. So 1200 divided by what number is 0.358? So these are a little tricky for some students. So when your x is on the bottom like this, I just tell my students, turn this into a proportion. So 0.358, put that over 1. And the 1200 over x is already a fraction. So now we're just going to cross multiply. We're going to do the butterfly method, as I like to call it. So 1200 times 1 is 1200. And x times 0.358 is 0.358x. It's kind of a little small, but that's okay. So now we have to get rid of that 0.358. So how do we do that? Divide both sides by 0.35. All right. So the 0.358s on the left-hand side are going to cancel out. 1200 divided by 0.358, 3,351.955. So 3,351.955. I'm going to say about 3,352. 3,352 feet we're talking, right? Right. Okay. That is a terrible 3. I apologize. All right. So the distance down the mountain is 3,352 feet. All right, last one. Surveying to find the distance at D from a house on a shore. We're trying to find the distance from this house at the top to this house on an island. Surveyor measures the distance from the house on shore to a point B as shown in the diagram. So the surveyor measures this distance, that is 40 meters. Then he uses a transit to find the measure of angle B. So over here he uses some transit to find the measure of angle B. That's 42 degrees. So now we need to use that information to find D. So this is a pretty nice one. They already gave us a triangle set up. So again, mark off your angle. This is the angle I'm focused on. What do they give us? They give us this 40, which is the adjacent side. And we're trying to find the opposite side. So take a second, pause the video. What are we going to use? Sine, cosine, or tangent? Hopefully you pause the video, and we are going to use tangent because we're trying to find the opposite and they gave us the adjacent. So tangent's going to work. So the tangent of our angle is opposite over adjacent. So the tangent of 42 degrees is our opposite D over our adjacent 40. So now this one is very, very similar to our tree problem. We're finding the tangent of 42. I got 0.9004, so I'm just going to say 0.9 equals d over 40. How do we get rid of that 40 on the bottom? We're going to multiply both sides by 40. So these two 40s are going to cancel out. And then 40 times 0.9, 4 times 9 is 36. So 40 times 0.9, you're going to get 36. So our distance is going to be 36 feet. Right? If you're not sure, double check 40 times 0.9, you should get 36. All right, so now the distance from the houses is 36 feet. All right. Hopefully that helped. If you have any questions, let me or let your teacher know. Again, my name is Mr. Bliss. Thanks for watching. Have a great day and stay safe and make good decisions.